Hello, could you hear my voice? Good evening. Could you hear my voice?
Yes, sir.
Oh, okay. Could you see that PPT? So all of you can see the PPT, ma?
No, sir.
Just once if you could see the PPT means you tell me. Now,
No, sir.
now it's clear. You could see, no?
Yes, sir.
Now the question number one. So we will discuss about the test whatever you have written in the yesterday. Okay. The question number one. How many optical active isomers possible in butane 2,3-diol? Tell me. How many? What is the answer? What is the answer? So what is the butane 2,3-diol? CH3, CH, OH, and CH, OH, and CH3. This is the butane 2,3 diene. Okay. So stereoisomer possible only because of the chiral carbon. Among the 4 carbon, which is the chiral carbon? Which is the chiral carbon? Which is the chiral carbon? So carbon 2 and carbon 3. So these two are the chiral carbon. So number of stereoisomer you can calculate by using 2 power n. N is equal to number of chiral center. If you are calculating, you will get 2 power 2, 4 isomers. It should be possible. But this compound contain plane of symmetry. So if you are writing this one, so you can write this as your CH3 and CH3. Okay, hydrogen, hydroxyl, hydroxyl, and hydrogen. Okay, so this, if you are seeing in the mirror, you can get the one more form and the last one form. So what are the possible? So one thing I will show you. OH, H, OH, H, CH3, CH3. And when you are putting the mirror, it will show one more isomer. OH, H, here H, OH, remaining methyl group, we will get that. So two isomers. And then you can try for OH, OH, CH3, CH3, H, H. But this isomer is not chiral one because it contains plane of symmetry. If you are cutting the molecule in the blue color, the above part is the mirror image of the below part. So it doesn't, even though it contains 2 chiral carbon, but it will not give the optical isomers. So if you are putting the mirror, it also won't give, but it exactly super impossible over the mirror image. So what are the conditions for a compound to be optical activity? Compound should contain chiral carbon. It should not have any kind of symmetry. And then the object and mirror images are non-superimposable. Okay. So if you are green color, you are taking the first one, second one, if you are superimposing over that, it will not superimpose. Exacta fit agadu. So this will be, and this will be the different isomer. Whereas you are seeing that yellow color, if you are putting the bottom, here if you are putting the mirror, here you are putting the mirror means you will get the mirror image. If you are taken to that into the above one, exactly super fit. So this two isomer is not possible. So the compound which having two the chiral center is even number, then it contain plane of symmetry, the isomer will be lesser number. So that's why it is not 4, it will give 2. So what is the answer? Which one is the answer? A, B, C, D. Which is the answer?
E options.
Huh? C. Right?
Sir,
Yes.
sir, in that, if you reverse that second configuration, means it is exactly fitting on the first one, no, sir.
If it reverse the
Sir, if we reverse the second configuration, means
this one,
it,
this one.
yes, sir, it's exactly fitting on the first one, no, sir. Then
No, You take the object and mirror image, you just superimpose over that. Okay, if you're reversing, the configuration will reverse. Okay,
Oh,
a
okay,
compound
sir.
one having the different configuration, compound 2 having the different configuration. For example, if you're checking 1 2 3, so it will go, it will give the S isomer, it will be the S isomer means, okay, it will be R and R. Okay,
Okay, sir.
so that's why these two are different. Hmm? Only thing, if you are having a number of chiral carbon, you just using this formula 2 power n, you can calculate number of stereoisomer. But the compound should not contain plane of symmetry. Okay, wow. Even number of chiral carbon irundhuna, you have to check the plane of symmetry. Okay.
Yes, sir.
Next question. Could you see that PPT?
No, sir.
Nova. It's not showing. And then there's question number 2. The rate of the relative rate of acid catalyzed dehydration of following alcohol would be. So look that first, which will give the dehydration. Dehydration mean what? What is the meaning of dehydration?
Removal
What
of
is the
H2O.
meaning? So removal of H2O. Correct. So when you are removing minus H2O, which will undergo faster rate? That is the question. So first you look at PQRS. You identify which is the primary one, which is the secondary one, which is the tertiary one. Okay. According to that, you have to say. So which is the primary one? So you have that P, the carbon attached to OH is attached to carbon. Then it become secondary. Correct? Then Q, the carbon which is attached with OH becomes CH2. It's a primary. Then the carbon which is attached to OH attached with 3-hydroxyl, then it becomes tertiary. That OH attached is there, no, that is primary. Now you have to arrange which will undergo faster rate. So please remember, when you have that, you have to remove that OH from the carbon, it undergo beta elimination.
Sure.
Okay. Yes,
The Q is, how is it primary?
because that is PCH3 CH2 hyphen CH2OH. It's not gives Mahatma, it's a hyphen.
Okay, sir.
The carbon is connected. Okay. So the structure is wrong, but the carbon is connected. Now the carbon, the hydrogen from the next carbon, it undergo water, it gives C double bond C, right? So this will be the product. Okay. Please remember, when you are removing the H plus OH minus ion, either in the acid catalyst or base catalyst, you have to remember. Here, what is there given? Acid catalyst. Acid catalyst means you have the H plus ion, right? So if the H plus ion is there means it will protonate the OH. So how it will protonate? When the COH become protonated OH2 plus. Okay, OH2 plus. When this water is removed means it will give a carbon which is positively charged. Okay, the remaining carbon will be as like that. Okay, so what is the involvement? Carbocation involved. When the carbocation involved now, you have to see that what is the stability of carbocation. Tertiary carbocation is more stable than secondary, which in turns more stable than primary, and then methyl carbocation. Why it is more stable? When the primary carbocation means the carbon which is surrounded with the 3 carbon atom, it gives plus a effect, it will stabilize the carbocation. Okay, according to that, you tell me which structure will be more stable, which will give the tertiary carbocation. PQRS, which will give
P, sir.
huh?
P.
P is a secondary carbocation. No, hello, you look the carbon attached with the functional group OH. Okay, then that carbon is attached with how many carbon? 2 carbon only. 2 carbon, 1 nitrogen, 1 hydroxyl. Then it is a secondary. The Q is the primary. R is the tertiary. S is the primary. So which will give the tertiary carbocation? Which will give? Which will give? So I told you that tertiary is more stable than when it acid catalyst meant the OH get protonated. If the OH get protonated, it remove the water molecule, will get the carbocation. If carbocation involved in the mechanism, tertiary is more stable than secondary, then primary, which in turns more than the methyl. So among the 4 carbon or 4 structure, which will give the tertiary carbocation?
R, sir.
So R is the first one. So second, which will give?
P.
Secondary carbocation. So which is the answer? First R and then P. Then which is the answer?
Option B.
Option
B.
correct. So option B is the answer. So now you may ask, sir, Q is the primary, S is the primary, why is coming first, then Q? So look that the carbon which is attached with 2 hydrogen, 1 hydroxy, 1 methyl, methylene group, CH2. Okay. Whereas this CH2OH is attached to adjacent with CH3, CH3. So which involve the, it can convert the primary into secondary carbocation. That's why R is stable than the S. Okay. Okay, ma? Is it okay?
Yes, sir.
Just a minute.
Sir,
Yes.
sir, 1 second, sir.
Hmm.
Yes, sir. Sir, in Q, hydride shift can take place. That's why it is more stable. But in S, hydride shift cannot take place. That is the reason, right?
Q. Tell me. Pardon?
In Q, hydride
Uh,
shift can take place because like the adjacent carbon has hydrogen, so the plus sign will go to the adjacent tertiary carbon atom. But in
uh.
S, that cannot take place because the adjacent carbon does not have hydrogen. Is that right?
No. That's wrong. So what I am saying, you have just a minute. I will draw it and tell you. You have that. Mm, erase this.
Sir,
In the S structure. Yes, no.
sir, can we say like the S structure, the phenyl group is closer, so it is more phenyl stabilized.
No. You cannot say like that. Just a minute. I will write that. You will get clear for it. pH C CH3 CH3. Okay. CH2 plus. If the protonation is coming means correct. Is it correct?
Sir, for which structure, sir? For S, sir.
Yes.
Yes,
For
sir.
a structure. So what will happen? Now it's a carbocation. In that case, that also be CH2 plus. Okay. Now the adjacent carbon having 1, 2, 3. Okay. So among the three, one group can migrate into this carbon. It gives CH3 C CH3 plus CH2 pH. Or otherwise this methyl group can go, and also you will get the carbocation. Now it is what type of carbocation?
Tertiary.
So you check with the Q structure. The CH2, if you are checking the carbon which is having two hydrogen, the remaining group, the remaining carbon which will be having CH3 pH and H. So that group you cannot migrate. What I am saying, this group you cannot migrate. So you can migrate only the two hydrogen. Correct? So
Sir.
if you are migrating also, you will get the same carbocation, that is your secondary carbocation. Am I right?
Sir, but
So
hydrogen can go, right, from OH.
yeah, okay. Anyway, OH will go ma. Once OH goes means you will get the positive charge. Okay. So that OH will go CH2 plus. Now the CH2 plus is a primary carbocation. Okay. After that, this hydrogen will go here. Correct. Then the carbon becomes secondary
Yes, sir.
carbocation. So S will give the tertiary carbocation, Q will give the secondary carbocation. So which will be more stable?
Sir, can you draw the phenyl structure and show?
So you have two types of just a minute. Okay, this bond will migrate. Otherwise, the methyl group, it also can migrate. It also can migrate to here. It will give the tertiary carbocation. So you have the phenyl group over here, methyl group over here. That's all. Okay. Okay, ma. Shall we
Yes,
move?
sir. Yes, sir.
So next one. Among the following non-spontaneous reaction is, which is the non-spontaneous reaction? First one, they have taken sodium alkoxide, then adding the water, it gives sodium hydroxide and alcohol. So non-spontaneous means the reaction which cannot happen on normal condition. Okay, so the water will comes up to down. Okay, it's a spontaneous, whereas it cannot go from down to up. It's a non-spontaneous. Why? If the reaction is happening means delta H should be, if it is spontaneous means delta H should be negative, delta S should be positive, delta G should be negative. Correct? Delta G is equal to delta H minus T delta S. So this one gives free energy which relate enthalpy and entropy. If delta H positive, delta S, sorry, delta S negative, delta S positive, and delta G should be negative means it's a spontaneous. Okay. If it is non-spontaneous means any of the first two can be positive or negative. If the delta S is negative, delta H is positive, definitely it will be the positive, then it become non-spontaneous. So among the reaction, when alcohol react with RMGX, definitely it will give the alkane, it will give. So it is a spontaneous reaction at room temperature itself. When you are alcohol and then you are putting that acetylene, it's acidic one, it can replace that sodium hydroxide, then it can be spontaneous. Then sodium methoxide, if you are reacting with water, it is exothermic reaction. It will give sodium hydroxide and water. That is also spontaneous. The only reaction with RNONA which will not. So this will be the answer of the question, non-spontaneous. Okay, is it okay?
Sir, why not D?
Hmm? D, it's taking place when the alcohol mixing with RMGX, it will replace that OH minus ion. It will give the hydrogen. So alkane will, Grignard reactions are readily reactor because Grignard reactions, that reagent itself, that will be, you keep it in the below the 0 degree. Okay, so when you are reacting means the carbon which is having the negative charge, it can take the H plus ion, so it will give RMGX, R dash MGX, R dash H plus remaining will go to the magnesium. That's why it's a spontaneous reaction. Okay.
Yes, sir.
Next one. The correct IUPAC name of C6H5COCl. When it's COCl means it's a benzoyl chloride, acid chloride. So how to name this? Chlorophenyl ketone. No, because it's a acid chloride. It's a acid chloride. The functional group is acid chloride. Functional group is acid chloride. So this is the functional group. So you cannot say chlorophenyl ketone. And the next one is benzyl chloride. It's a common name. When the benzyl chloride means what is they saying? C6H5CO, then it is called benzyl. When the chloride attachment, benzyl chloride. Bromide attachment, benzyl bromide. It's a common. And then phenyl chloride ketone. That is also not possible because it's not a ketone. Then the last one, what is that? Benzene carbonyl chloride. It's a answer for that. because for the acid chloride, what is the name? You can say benzene carbonyl chloride. Okay. COCl, you can say as a carbonyl chloride. What is the remaining is there? Benzene. That's a benzene carbonyl chloride. Okay. Okay, ma? Is it okay? Say, you have to say no, yes or no. Then we can go faster, no?
Yes, sir.
Then last one. So fifth one. Predict the product of the following reaction. So what is the reagent given? Sodium borohydrate. Right? Sodium borohydrate. Sodium borohydrate. Okay. So what is the purpose of sodium borohydrate? Sodium borohydrate. It's a weak reducing agent. It's a reducing agent which can reduce aldehyde and free ketone. Okay. But the compound which has given, what is the functional group? What is the functional group? What is the functional group given? What is the functional group given, ma?
Ester.
So the ester cannot reduce by sodium borohydrate. Then what is that answer? What is that answer? So first they are given ethyl acetate to ethanol and acetic acid, acetylene. So it's not a dehydrating agent. It's a reducing agent. Reducing agent means it will reduce, isn't it? So the no reaction will take place. That is the answer. Okay. Is it okay? Doubt Ruka? Shall we proceed?
Yes,
Yes,
sir.
sir.
Next. Very good question. So they have taken phenyl cyanide. Okay. First they have reduced into using SNHCl and then they have diazotized. Then they have given a different types of product. We'll see. First one, you take phenyl cyanide. When the cyanide reduced means what you will get? Is a single bond part, triple. Tin and HCl is a reducing agent, right? When it reduce, what will happen? Cyanide reduce ஆனா என்ன கிடைக்கும்? And the cyanide reduced means now what? You have to add the hydrogens. So one bond if you are cleaving CHNH, imine. So again if you are cleaving two bond, then CH to NH2. So what is the product you will get? You will get phenyl amine. So the amine group which is not connected directly to the benzene ring, but it was separated with the one CH2. Now the amine is aliphatic amine or aromatic amine? Now the amine is aliphatic or aromatic?
Aliphatic.
And the aliphatic amine reacted with HNO2. How you will get the HNO2? When NaNO2 reacted instantaneously with the HCl at the temperature of 0 to 5 degree, it will give HNO2. When you have the HNO2 reacted with aliphatic amine, it will give, what is the product? You tell me, you have studied, no. HNO2 reacted with methylamine, what you will get?
Option D.
What you? Option D, okay. Generally, I'm asking.
Alcohol.
Methyl alcohol. Suppose if the NH2 attached with benzene, what you will get?
Diazonium salt.
Very good. So you will get the diazonium salt. Now the answer is, what is the answer? CH2. H. So now our answer is option D. Okay. Clear, ma? Okay, we'll go to the next one. So what is the next question? So you have to answer immediately, no? It's a one more question. You are taking that much time. So arrange the following in the decreasing order of their basicity. So what is the decreasing order of basicity? So what is basicity? You looked at the basicity is based on the NH2 group, right? If the lone pair availability is more, the basicity is more because the base means it can readily accept the proton, right? So among the three compounds, all are having amine which can readily accept the proton. There is no doubt about it. Am I right? Am I right? So the first three, all the threes are aliphatic amines which can abstract the proton. But the first one, the CH2NH2, which is attached with a double bond, and the second one, which is attached with a single bond, that means that CH2NH2 is attached with OR group. Okay. For the first one, the OR group is CH2 double bond CH. For the second one, it becomes CH3 single bond CH3. And the third one, it becomes CH triple bond CH. Correct? Or CH with C. It becomes C. Correct? Now, the amine, which is having lone pair of electron, when the CH2 is there means it can donate the proton. Okay, so it can donate the electron. So according to plus A effect. What is plus A effect? If the electron donation through the sigma bond, then it is called plus A effect. So when the plus A effect is taking place, when you have the saturated system, if there is a electronegativity difference, then the electron will migrate towards more electronegative atom. The electron pair migrate towards more electronegative atom. That's why the carbon bears a positive charge. So definitely this carbon will bear a partial positive charge, and this nitrogen will bear a partial negative charge. So when this carbon is partial positive charge, it can pull the electron from the adjacent one. So according to that, the first one is having CH2 double bond CH. So it is a unsaturated compound because it contains a double bond. So it cannot give the electron. Instead, it can withdraw the electron. So what we are expecting, it has to give. So then this will become plus A minus A effect. Minus A effect means it will withdraw the electron. So this carbon, it's flanked between one NH2 group, another one CH2 double bond CH group. So the CH2 double bond CH group become I minus AF. That means it can withdraw the electron because it will go like this polarization. Okay. So it has, in the second case, it's a methyl group. It can donate only the electron. The group is plus size. The third one, it become CH3 triple bond. Then it also minus A group. So we know that when the plus A group, it increases when attached to the NH2 group, it increases the basicity. Please remember, when the NH2 is attached with plus I group in alkyl system, it increases the basicity. Now you tell me among the three, which is more basic? Which is more basic? Which is more basic, ma?
The
Hello.
second one.
So second one is more basic. And then which அதுக்கு அடுத்த next என்ன வரும்? Second one அப்புறம். So ஒரு pi bond இருக்கும் போதே இது electron withdraw பண்ணுது. In the third one ல you have two pi bonds. Then second become, so first become, so option
More basic.
option which option is correct answer?
Option C.
Okay. Okay, va? Answer is clear? Is it clear, ma? See, you have to answer. No, I'm telling this much. You are
Yes,
not
sir.
telling it. Somebody, if you are telling, so I can feel that you understood that concept. So next one. In a reaction, a secondary amine forms nitrosamine, which on heating with phenol and corn sulfuric acid give green color solution, which turns blue on adding alkali. The reaction is called. So when the HNO2 is used, okay, secondary amine form nitrosamine amine means it's a Lieberman reaction. So the Lieberman nitroso reaction only you can convert the secondary amine into or N nitroso dialkyl amine. So it will become yellow in the oil when you are treated with the phenol and concentrated sulfuric acid. It gives clean color. So after that, if you are adding alkali, it become blue. So then the reaction is called Lieberman's nitrosation. Okay, Lieberman nitrosation. Fry's reaction means the phenol which having OCH3 group. Okay, Berkin's reaction means the aldehyde which are having a reaction with the active methylene compounds, you will get the cinnamic acid like that. That the Berkin's reaction. Etard reaction means toluene oxidized into benzoic acid, that is Etard reaction. Okay. And the next ninth one. Among the following, most basic compound is para-nitroaniline, benzylamine, acetanilide, and alanine. First, we'll see the structure of the compound. So this is para-nitroaniline. Okay, then benzylamine, and then acetanilide. NHCO CH3, then aniline. So when you're having aliphatic amine and aromatic amine, which is more basic compared to aliphatic and aromatic? Which is more basic, aliphatic, aromatic? When you are comparing aliphatic amine and aromatic amine, which is more basic?
Aliphatic.
So among the four amines, which is the aliphatic amine?
Benzene.
Among the so option B is the aliphatic amine, correct? Because the NH2 attached with methyl group. In all other case, the NH2 is attached with the benzene ring. When NH2 attached to the benzene ring, the lone pair of electron involved in the resonance, it make less availability of electron on the nitrogen atom. So the electron which involved in the resonance. Whereas in the benzylamine, the electrons are free. So it can readily accept the H plus ion, then it become a good basic. Okay? Is it okay, ma? Keep on, I'm asking, nobody answering. Simple thing, aliphatic amines are stronger amine than. Now, the very good question. Arrange the following increasing order of basicity: aniline, para-nitronilin, para-toluidine, and para-methoxyaniline. All are aniline. So there is no difference because all are amines, right? So we'll write the structure of first. First one what? Para-nitronilin. So NH2, that para portion, the NO2 group is attached, and then para-toluidine, that is nothing but NH CH3 NH2, and then para-methoxy aniline. And then aniline. Among the four, okay. So now you look this, you have aniline. This is para-nitroaniline, para-methylanilin, para-methoxyaniline. Now you know that the methyl groups are plus A group. So the methyl groups are plus A group. Whereas the nitro groups are minus A group. So another one, you can say it is electron withdrawing group. Electron withdrawing group. These two are electron releasing group. When the groups, so aniline all NH2 at the fourth position only you have the difference. Okay, so definitely it will be the comparable one. It never be the strong or weakest. Okay, it will be the middle one. Now the electron releasing group which can release the electron to the ortho and para position. Okay, when the carbon benzene is bonded with OCH3 and CH3, it can release the electron, and the ortho and then para position will be electron rich. Okay, so according to that, so the lone pair of availability will be more on the nitrogen. Okay, para-methoxy is a stronger electron releasing group, so the lone pair availability is more. Whereas the methyl, the electron releasing group, the lone pair availability is more. Okay, so definitely this amine O methoxy become the stronger one. So you tell me the order. Electron withdrawing group can withdraw the electron. Once NO2 is electron withdrawing, no, the NH2 nitrogen will go to the ring. It involved in the ring, whereas it will release the ring. These two group release the ring, but the NH2 group and NO2 group withdraw the ring. So definitely it will be the least basic. So now according to that, which one the first one? Para methox is the strongest base, strongest basicity, and then para-methyl, and then aniline, and then para-nitronilin. What is the answer? Which one is the answer? Which is the correct answer?
C.
Yeah. So C is your answer.
Sir, why is methoxyaniline greater than toluidine?
O oxygen is more electronegative, no? And then NH2 group is there. That OCH3 can donate the electron because of the lone pair of electron available on the oxygen.
Sir,
But the methyl oxygen having the lone pair of electron, it can involve the resonance with the benzene ring. Okay. In the methyl group, it can donate the electron through hyperconjugation. Okay. The principle behind that plus I group is there, no methyl group la 3 hydrogen. அதுல இருக்கக்கூடிய ஹைட்ரஜன் வந்து ஹைப்பர் கான்ஜுகேஷன்ல தான் இன்வால்வ் ஆயிருக்கும். ஸோ ரெசனன்ஸ் பிளேஸ் கிரேட்டர் ரோல் தன் தி ஹைப்பர் கான்ஜுகேஷன். ஓகே.
Okay.
sir, here, but oxygen being electronegative, its tendency to donate will be less, right? As compared to an electron donating group like our group. So it will reduce the donating capacity.
No. When if it is oxygen having the lone pair which involve the which can donate more, the lone pair can share. Okay. So OCH3 group, that oxygen having 2 lone pairs, that lone pair only involved in the resonance. Okay. We are not telling that completely it goes to that. Okay. It makes the ortho and para portion become more reactive in the benzene ring. So the lone pair having conjugated with your pi bonds. Okay. When you are comparing to your halogen, oxygen is less negative, correct? If you are comparing fluorine, oxygen is less negative, electronegative, no?
Yes, sir.
So it can donate, that's all. Because இதுல வந்து electron deficiency எங்கேயுமே இல்ல ஆக்சிஜன் கார்பன் கிடையில. So the lone pair only involved in the resonance. அதுவும் இந்த ortho and para position make it more electron rich. Okay.
Yes, sir.
It's convincing you, or still you are having doubt?
Yes, sir. Got it.
That is why you are getting that paramethoxy. See, when the benzene ring attached with a single bond, all are electron donating. Okay. If it is NH2, if it is OH or OCH3, whatever it is, it will be electron releasing, except halogen. Okay. Halogen is more electronegative, so it can have the bonding electron towards this side. Okay. Other than that, all are electron give to the ring. So if the group attached to a group having the multiple bonds or positive charge, that will pull the electron. Okay.
Yes.
That is electron withdrawing group. That's why NO2 is the electron withdrawing group. Okay.
Yes, sir.
Now we'll go to the next question. So the correct IUPAC name of FeC5H252. So C5H2 C5H25 no இதுதான். Okay. C6H5. This is the C6H5 minus ion when it bonded with iron. Okay. So this 2 minus means ion will be the 2 plus. Correct? இதோட நேம் பாத்தீங்கன்னா வாட் எவர் we are writing no அதோட நேம் cyclopentadienyl anion. Cyclopentadienyl anion. So how many cyclopentadienyl is there? 2 is there. So already ligand having penta group is there. So if you are naming, it should be bis because 2 is there. That's why bis cyclopentadienyl ion 2. So where is there?
E
Which is
option.
the answer? So option
D.
okay, because this only you have to say. You should not say bicyclo. Then dicyclopropanol also you cannot say. Cyclopentadienyl ion 2. So the first you have to always name the ligand and then metal atom. Okay.
Sir, why is A option wrong, sir?
It's a bi. When you have to use bi, mono, bi, di,
Yes,
tetra.
okay, sir.
If the ligands are chloro, then you can use ligand itself having the substitution penta, hepta. When the ligand is having name, the ligand name having your mono, di, na, that time you have to use bis, tris, tetrakis, pentakis. So this is the nomenclature of coordination compounds.
Yes,
Correct?
yes.
The next question. Consider the following statement. The tris oxalato cobalt 3 minus complex is a diamagnetic, gain stability through chelation. Number 2, hexa nitro cobalt 4 minus is an inner orbital complex having D2sp3 hybridization and it's paramagnetic, and complex tetrachloroplatinum 2 minus is a square planar and diamagnetic. So what is the answer? So oxalate means OX2 minus, right? Oxalate means OS2 minus. OX2 minus because COO minus and COO minus. Definitely it will be chelated because it's a bidentate ligand. Correct. So cobalt. What is the oxidation number of cobalt? 6 means cobalt 3 plus. Correct. Sari tappa.
Yes, sir.
And the second one, NO2 minus, 6 NO2 minus, then cobalt become 2 plus. And the platinum, it's a 2 plus. So definitely it is a square planar and diamagnetic, it is correct. Now you check scandium, titanium, vanadium, chromium, manganese, iron, cobalt. So 27 is the atomic number. When you are writing electronic configuration, so argon is 18, remaining 9 no, 4s2, 3d7, correct? Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, 27. So now it's a cobalt 3 plus. 3 plus means 2 electron from this one, d6, 3d6. And then cobalt 2 plus means 3d7, right? And the 3d6 means how the electron will be. So you know that it will be splitted 1, 2, 3, 5. When you're filling the electron for the 6 electron, because it's a oxalate ligand, it's a chelated, then the electron will be 1, 2, 3, 4, 5, 6. So the remaining you are having 2 orbital vacant, then it is a paramagnetic. So it's a diamagnetic, then it gains the stability. When it 3d7, what will be that? Copal 2 plus. One, two, three, 4, 5, 6, and 7. One unpaired electron is there, then it is a diamagnetic. Okay. So what is the answer? So first one is it's a complex is diamagnetic through chelation, correct. Second one is it involved the D2sp3 hybridization, there is no doubt about it. Then it has one unpaired electron, it's paramagnetic. Then third is a square planar diamagnetic. Then what is the answer?
B of
So true, true, true.
Sir, NO2 is a strong ligand.
NO2 minus
Is a strong ligand.
cyanide, carbonyl, they are very strong ligand. Okay, they are the moderate ligands. Okay, உனக்கு வந்து வீக்காவும் இருக்காது டூ ஸ்ட்ராங்காவும் இருக்காது மெட்டல் ஆட்டம் என்ன ஆக்சிடேஷன் ஸ்டேட்ல இருக்குன்றத பத்தி இது ரியாக்ட் ஆகும் ஓகேவா
Sir, then in the second case where you drawn with the red color pen, here only one d orbital is there, right?
the filled orbital can also take part in the hybridization we நம்ம எப்பவுமே வந்துட்டு empty orbital தான் hybridization involve ஆகணும்னு சொல்றது கிடையாது the filled orbital also can involved in the hybridization okay
Okay, sir.
but you have two orbital you can accommodate one more electron that is the case
Yes, sir.
okay shall we move shall we move pa
Yes, sir.
So, which is one example for the coordination isomerism. So, what is coordination isomerism? The ligands are same, the metal can interchange. Okay, correct? So, ligand same, same ligand, metal can interchange. It gives coordination isomerism. Okay. So, first one case, you have the chromium, water, and chlorine. So, one of the chlorine from outer side of your sphere, it's coming to inner side. So, what is that? What type of isomerism is this? First one. First one is the ionization isomerism, correct? Hello.
Yes, sir.
The second case, CONH3 5 times NO2 Cl2. So the NO2 you are
Linkage.
written here. So linkage isomerism. And the third case, bromide inside இருக்கு bromide வெளியே போயிருக்கு sulfate வெளியே இருந்தது உள்ள வந்திருக்கு அப்ப என்னது சொல்லுங்க என்ன ஐசோமரிசம்
Ionization.
so then D case first NH3 connected with chromium cobalt is connected with cyanide and another one cobalt connected with ammonia and chromium connected with cyanide so here ligand same metals are changed then what is your answer
Coordination.
so D is your answer okay is it clear ma
Yes, sir.
Yes, sir.
so shall we go further so which of the following has an optical isomers 14 So look here, cobalt plus, so CH3 and Cl. Now the structure become like this. Here you have one Cl, remaining are NH3. So it won't show the optical isomerism. And the second case, you have cobalt, 4 water molecule and one, this one will be connected ethylene diamine. Remaining are 4 water molecule, so it won't show the optical isomer. And the third one, cobalt, okay, these two having ethylene diamine and the remaining having 2 NH3, but one is CO2 plus and another one is CO3 plus. So which will show the optical isomerism? Here is the trick.
Option D.
Why option D? Your answer is right. Why it's option D?
In C, ethylene EN is
Good.
double
So bidentate ligand is 1. Okay. In the D case, you have 2 bidentate ligand and 2 ammonia. Here you have 1 bidentate ligand and 2 ammonia. So it can give the like square planar complex. Okay. So that complex itself not stable. So it cannot show that isomerism. So when if it is like this means it won't show that optical isomerism. So when you have the structure, when the octahedral, when the octahedral structure is there, no. So if you are having octahedral structure like this, the 2 ligands will be connected like this, and the ammonia become like this. Then it will show the optical isomerism. Okay. The option D is your right answer. The next 15th question. We have to move faster. So the crystal field splitting energy of high spin D4 octahedral complex. When you have the octahedral complex, what is time now?
7-9, sir.
So another 20 minutes is there, no? Right, okay. When you have octahedral structure, so the crystal field stabilization energy become, how it will be split? T2G and EG, right? Am I correct, Pa? T2G means triply degenerated, EG means doubly degenerated. So what is that difference is that it will give the CFT value. Okay, crystal field stabilization energy, CFSC. So this difference is the CFSC. Now they tell that high spin. High spin means the electron can you can fill singly in all the state. Low spin means first you have to pad up and then you have to go for the filling up. Correct? Huh? When you have the D4 you can spill like high spin and low spin. How you can spill? T2G3 EG1, it's a high spin. If it is T2G4 EG0, it's a low spin. Are you agree? Is it correct? Is it correct or not? Hello? Those who are on the online, are you hearing?
Yes.
So now So for the crystal field stabilization energy, CFSE is equal to, so point minus 0.4 times into number of T2G plus 0.6 level the energy get raised of EG electron. If it is high speed means this is the electronic configuration minus 0.4 into 3 plus 0.6 into 1. Minus 0.4 into 3 become minus 1.2 plus 0.6. So the answer is minus 0.6. Correct? Delta 0 ங்கிறது crystal field stabilization energy வருது. Then you tell me what is that answer? Which is the answer?
Option B, sir.
Option B is the answer, right? Clear? Clear?
Yes, sir.
Sir,
ஏன்
avoid
யார்
getting that energy 0.6 and 1.2.
See, 3 into 0.4, how much? See, here, look here, T2G, 3 triple E degenerated, no, EG2 doubly degenerated, no. So, the 2 electron level க்கு இந்த 3 electron கீழே இறங்கிருக்கு. That is why minus 0.4 into T2G. T2G ங்கிறது number of electrons in the T2G orbital. Plus, in the 3 orbital na you can accommodate 6 electron. That's why 0.6 they have taken. So 0.6 into EG electrons. Okay. So in the T2G you are having 3 electron, EG you are having 1 electron. So 0.4 into 3 it become minus 1.2. 0.6 into 1 it become 0.6 minus 1.2 plus 0.6. What is the answer? Clear?
Yes.
புரிஞ்சுதாப்பா?
Yes, sir.
That's why 0.6. So when you are looking that answer, you have to very careful. Okay. So next, which of the following reaction of glucose can be explained only by its cyclic structure? So we'll see the answer one by one. Glucose is oxidized by nitric acid to gluconic acid. So when the glucose means in the open chain structure, we are telling that it having 5 hydroxyl group and 1 aldehyde group. Correct? So among the 5 hydroxyl group, 4 are secondary alcohol, 1 is primary alcohol, and the last the group is aldehyde group. When the glucose is oxidized into gluconic acid means if the structure containing aldehyde, then only it will give the gluconic acid. Correct, Appa?
Yes, sir.
So the option 1 it's not cyclic structure. Correct? It's because of your open chain structure. And then option C you looked at, glucose react with hydroxylamine to form oxide. So when the hydroxylamine react with glucose, when the aldehyde is there means then it will react. Okay. So in the open chain structure only it has the aldehyde. So definitely option C also correct answer, not answer. And then option B, pentaacetate of glucose does not react with hydroxylamine. So it gives some answer because it is having 5 hydroxyl group and then 1 aldehyde group. If aldehyde group is there means definitely it has to react with your hydroxylamine. So the pentaacetate of glucose does not react acetate means what? Then it has cyclic structure. So what about your D? Glucose form pentaacetate because it having 5 OH group, that's why it forming. அதனால so A, B, C, D ல B is your answer. Correct? Clear? Oh, is it
Yes,
clear
sir.
or not? See, it should not be one way. If you are answering, it will helpful, you know. So whatever doubts you are getting, you can clarify. No. Okay. Then 17. Alpha helical is a structure feature of polypeptide, nucleotide, starch, and sucrose. Please remember, alpha helixங்கிறது வந்து the ring coil like structure. இப்போ நம்ம spring இருக்கு இல்லையா, அந்த spring மாதிரி structure வருது. எதுல வரும்? பாலிபெப்டைட்லயா, நியூக்ளியோடைட்லயா, ஸ்டார்ச்லயா, சுக்ரோஸ்லயா? Starch and sucrose are carbohydrate. Sucrose is a disaccharide. Starch is a polysaccharide. Now the alpha helical structure feature எதுல வருது? எதுல வரும்? நியூக்ளியோடைட் மீன்ஸ் என்ன? Sugar, phosphate, and then your base. Correct? What is nucleotide? What is nucleotide, ma?
The sugar, phosphate, and base.
Base. Nucleoside means? Nucleoside means? Nucleoside means? So have you studied or not that lesson? See, each lesson you take as some important points. Okay, that if you are remembering, you can answer any type of questions. It's not at all matter. Okay, so each topic you have to prepare a important clues and answers. Then only you can answer. Polypeptide means what? What is peptide? What is peptide? For all of you in the online,
Yes.
yes, you tell me no. Some answer. If it is wrong, also no problem. Then you can learn no. What is polypeptide? What is peptide? What is peptide?
Two alpha amino acids linked.
Amino acid.
Two alpha amino acids.
Linking means you will get peptide. Okay, one amino acid linking with one more amino acid, that means one amide bond is forming, means it's a peptide. Okay, when the two amino acid forming one amide அப்படின்னு சொன்னா it's a dipeptide. Three amino acid means tripeptide, but it will contain two CONH bond. Polypeptide means if you are having number of CONH bond, then it is a polypeptide. Okay, nucleotide DNA RNA structuresல இருக்கிறது தான் நியூக்ளியோடைட். ஓகே, ஸ்டார்ச் கார்போஹைட்ரேட், சுக்ரோஸ் கார்போஹைட்ரேட். So when the polypeptide structure,
Sir, what is
yes,
nucleoside?
when the nucleic acid having without phosphate group, okay, sugar and base, then nucleoside.
Okay.
Okay, this is the difference. Look here. So in the alpha helical structure, it's explain about the protein structure. So protein, you have primary structure, secondary structure, and tertiary structure. So the primary structure tells how many bonds is present. For example, polypeptide, monopeptide, dipeptide, tripeptide. So it can explain about that. But the secondary structure having two different. One is alpha helical structure, that is the structure, protein structure, which is stabilized by the hydrogen bond, that will be explained by the alpha helical structure, as like your spring. And then beta affiliated structure. So now you tell me the alpha helical structure is for what? Nucleoside, starch, and sucrose, and polypeptide. The answer is polypeptide. So I don't know whether I'm giving a correct clue to you or not, because if you are not answering means so நான் சொல்றது புரியுதா புரியல உங்களுக்கு?
Yes, sir.
சரி, ஜஸ்ட் உங்க ஜஸ்ட் ஆப்போசிட்ல வந்து எஸ் ஆர் நோ, நீங்க ஜஸ்ட் இன்டராக்டிவா இருங்க. அப்பதான் எனக்குமே வந்து நான் சொல்லி கொடுக்குறேன் அப்படின்ற ஒரு ஃபீல் இருக்கும். ஓகே, இல்லைன்னா நானே ஏதோ ஃபிகர் பார்த்து சொல்ற மாதிரி இருக்கும். ஓகே, நவ் among the L serine எல்லாமே சேம் ஸ்ட்ரக்சர் தான் கொடுத்துருக்கு. கரெக்டா? எல்லாமே சேம் ஸ்ட்ரக்சர் தான் கொடுத்துருக்கு. ஆனா கவனிங்க, COOH, CH2OH, H, NH2 எல்லாத்துலயும் பாருங்க none of this ன்னு கொடுத்துட்டு A, B, C. நம்ம இதுக்கு முன்னாடி கொஸ்டின் என்ன? ரைட். A, B, C, D ன்னு கொடுத்துட்டு they are asking. ஸோ ஜென்ரலா கவனிச்சிங்கன்னா இந்த கேபிட்டல் டி, கேபிட்டல் எல், கேபிட்டல் டி, கேபிட்டல் எல் இந்த கான்ஃபிகரேஷனுக்கு பேரு ரிலேட்டிவ் கான்ஃபிகரேஷன் அப்படின்ட்டு பேரு. இந்த ரிலேட்டிவ் கான்ஃபிகரேஷன் எப்படின்னு கேட்டீங்கன்னா, when you have the chiral carbon in the chain, if the chiral carbon having, so it will be applicable only for your amino acid and then carbohydrate. In the case of carbohydrate, hydrogen and hydroxyl. In the case of amino acid, hydrogen and NH2. So when the hydrogen on the left hand side, amine group on the right hand side, if the reduced group in the bottom, oxidase group on the up in the Fisher projection, then it is say it is a D amino acid. If the reverse of this, if the nitrogen on the left hand side, hydrogen on the right hand side, oxidase group and reduced group, it is L amino acid. Okay, L amino acid. Now they are not given like that. So then how you can say, sir? Yes, we can. So how you can say? How you can say? You can assign the configuration. You can assign the configuration. By using the configuration, we can say. So now you look that first in the B case. So you have to give the order. So if you are giving the order, what are the group is there? COH is there, CH2OH is there, hydrogen is there, NH2 is there. So what are the rule you can follow? One is atomic number. Number two is adjacent atom. Number three is multiple bonds. These are the rules you can follow. Multiple bonds. These are the three rules you can follow for the order. So now you can take that, you answer it. So which is having first according to the this one, NH to become the first one order, and then COOH second priority, and then CH2OH, and then hydrogen. So 1, 2, 3, 4. 4 is the lowest priority. So all the case, it's a 4, it's a 4, it's a 4. And then which is the one? Nitrogen is the one. Nitrogen is the one. Nitrogen is the one. And then COH is 2. COH is 2, 2. And then CH2OH is 3, 3, 3. Now you see the 1, 2, 3 direction, which is having clockwise. 1, 2, 3 clockwise. 1, 2, 3 is anti-clockwise, and 1, 2, 3 is clockwise. So actually Answer C and D having the same answer. One, two, three. ஒரு கான்ஃபிகரேஷன் சேஞ்ச் பண்ணணும்னா இதை சேஞ்ச் பண்ணணும்னா CH2 அங்க ஓடிடும், H கீழே வந்துடும். 1, 2, 3. So okay, இதோட ஆன்சர் மட்டும் we'll discuss because both C and D having the same configuration, right? If you are giving, but இதுல வந்து D க்கு பாத்தீங்கன்னு வச்சுங்களேன், D க்கு வந்துட்டு S கான்ஃபிகரேஷன் வரும், C க்கு வந்து R கான்ஃபிகரேஷன் வரும். கரெக்டா? Am I right or not?
Yes, sir.
So C having S configuration, D having R configuration. Sorry, C having R configuration, D having S configuration, because fourth group on the horizontal. So now I will check it and tell you. Okay. So R group இருக்குதுன்னா answer C and D and C தான். ஒரே நிமிஷம் இருங்க. When you are exchanging, the hydrogen goes here, NH2 comes here. So hydrogen on the left, NH2 on the right, reduced and oxidized coming now. So 1, 2, 3 clockwise directionல இருந்து ஹைட்ரஜன் வந்து ஹரிசாண்டல்ல இருக்கு. So சிம்பிளா சொல்லணும்னா ஹைட்ரஜன் லெஃப்ட்ல இருந்து 1, 2, 3 வந்து clockwise directionல இருந்ததுன்னா then you call it as L. So according to the answer it was D. Okay, the answer is D, no doubt about it. But the only problem, you cannot say based on your RS configuration, because RS is not directly related to D and L. Okay, when you are exchanging this, nitrogen coming here, hydrogen goes there. So 1, 2, 3 direction also will change. When your two exchanges doing, CH2 you are bringing over here, the C, hydrogen going to the third position. So you have to exchange one more thing, NH to go above and COH. Two interchange if you are doing, then the configuration become 1, 2, 3 reverse ஆயிடும். ஹைட்ரஜன் வந்து left hand side வந்துடும். அதனால இது வந்துட்டு D serine, C become D serine, D become L serine. Okay. ஓகே, நம்ம ஆர்கானிக் கன்வர்ஷன் மட்டும் கொஞ்சம் முடிச்சிருவோம் ஒண்ணே. ஓகே, நம்ம you have any classes after this?
No, sir, you can take the paper.
Okay, it's a 19. In Gold's reaction, instead of phenol, phenoxide ion treated with carbon dioxide. Why? What is the reason?
Phenoxide ion is more reactive.
Why it's more reactive? Because it's an anion, it involves resonance more than your phenol. Okay, they are more basic than your phenol, that's why. So more acidic than your phenol, because they are O minus ion which involved in the resonance. Okay, so it can readily react with your carbon dioxide. That's good. The next question. What happened when phenol is treated with hydrogen in the presence of nickel? So phenol, hydrogen nickel means what is that reaction?
Reduction.
So what reduction it happened? So the benzene ring will reduce and then give cyclohexanol. Hydrogen nickel means hydrogenation. So you have 3 double bonds that will be reduced. Okay. So the OH will not affect. Okay. Clear, ma?
Yes, sir.
So same phenol treated with zinc oxide. Zinc, what is your answer? When it treated with zinc, what is your answer?
Benzene.
It become benzene. Good. Good, good. So write the chemical reaction of aniline with benzyl chloride and then write the name of product obtained. So anyone can answer? So what is
Sir,
the name of it?
N-phenyl benzamide.
Very good. N-phenyl benzamide. So NH2 can react with C6H5 COCl. So one of the hydrogen and chlorine will go in the presence of sodium hydroxide. It will give. This is the when you are using OH phenol, the same reaction will go. So both the reactions are called Scott-Bowman reaction. NHCO C6H5. What is the name of this compound? N phenyl.
Benzamide.
Very good. Okay. So next question. Is it useful, ma, all of you? When we are discussing, no?
Yes,
Is
sir.
giving any clue? Only one person getting answer, huh? Is it useful or not?
Yes, sir.
So 12 members are there, 11 members apart from me. So only one person telling. What about others?
Yes, sir.
2.
Yes, sir.
Yes, sir. Yes.
Yes, sir.
So why do amine behave as a nucleophile? So what is nucleophile?
Rich in electron.
Rich in electron. So I told you what is the difference between nucleophile and base. Nucleophile means the ease of formation of negatively charged or neutral molecule with the carbon. The ease of formation of bond with the carbon of negatively charged, okay, or neutral one. Then it is called nucleophile. So why the amine behaves in nucleophile? Since amine containing the lone pair of electron, which is not involved in any type of bonding, so it can readily donate, so it become a nucleophile. Okay, because amines are Lewis bases, that also you can write. Amines are Lewis bases. It has one unpaired electron, that is lone pair of electron. That lone pair of electron can donate or making bond with the carbon. Then that's a reason why it becomes a nucleophile. Okay. Next question. Copper sulfate pentahydrate is blue in color, whereas copper sulfate is colorless. Simple answer. Because when the copper sulfate are in the pentahydrate, it become copper H2O 5 times and then sulfate. When the water is goes, it become copper sulfate. That means Cu2 plus SO4 2 minus. You may ask, sir, suppose if a copper pentasulfate எடுத்து test பண்ணா, we can get copper and sulfate. Definitely we will get the test for copper and sulfate because water only as a ligand, so the copper can give the test. Whereas copper sulfate monohydrate, when you are heating, the copper sulfate pentahydrate become copper sulfate. Okay, so the copper SO4 2 minus, then it becomes Cu2 plus, right? When the Cu2 plus it gives DD transition. The copper in the copper sulfate pentahydrate, water behave as an
Sir,
ligand. Yes.
sir, here will all the 5 water will be as ligand or only 4 and one?
Only four. Only four. Only four. Yes, you are right. Sorry. The only four as a ligand. The fifth one become other than. Okay. Good. Thank you. So the four water molecule become a ligand. Then it has the DD transition can take place. That's why you are getting the blue color. In the copper sulfate, no hydrate is there. That's why there is no DD transition. It's a colorless. Okay.
Yes, sir.
Hmm. Good. Good. Next. A coordination compound of chromium chloride 4H2O precipitate silver chloride when treated with silver nitrate. The molar conductance of its solution corresponds to a total of 2 ions. Write the structural formula of the compound and name it. So what will be the compound? When the silver nitrate treated Ag, AgNO3 treated, if you are getting AgCl, that means the chloride ion will be precipitated. Okay. Then what is that? So the molar conductance correspond to total 2 ions. So definitely one chlorine will be other side. The remaining one will be the chromium. So Cr H2O 4 times and Cl2 then Cl. If you are treating this one, it gives two things. What are the things? CrH2O 4 times Cl2 plus and then Cl minus. Correct? Totally 2 ions. When you are treated with, it will give the Ag, this AgNO3. It can react with AgNO3. It gives the AgCl. Correct? So this will be the complex. What is the name of this complex? 4 water இருக்கு 2 chlorine இருக்கு. So tetra aquo dichlorido chromium. You tell me what is that? Chromium 1 or 2 or 3? Oxidation state. Water is a neutral ligand.
3.
So chromium 3 chloride is the answer. Correct? So LMA satisfied the.
Yes,
So
sir.
this is your answer. So next question. So amino acids are amphoteric nature. Give the reason. Simply when you are having amino acids NH2 COOH, some R group. Okay. So this is acidic nature. This will be the basic nature. So when it become NH3 plus COO minus RR. So this form is known as zwitter ion form or amphoteric form because the carboxylic acid can lose the proton, the amine can abstract the proton, so it will it will be the equilibrium. That's why they are amphoteric in nature. Okay. When the H plus ion is more means it will become NH3 plus. When the basic ion is more means it becomes COO3 minus. So it is in the equilibrium, it becomes zwitter ion. That is why we are saying it's amphoteric in nature. Explain why COO is non-polar, ROO is a polar. It's a very good question. In the carbon dioxide, it become like this. In the ether, it become like this. And then one more thing, ether has the lone pair of electron this side. Okay. Now, do you remember that what is your chemical bonding? The dipole moment towards this direction, and same way they are towards this direction. So the mu is equal to 0. Whereas the oxygen is more nature, that this nature become, so totally the dipole moment is not equal to 0. That's why ROR is polar. Correct?
Sir.
Hmm.
Sir, can we tell in terms of electronegativity, sir?
Yes, you can tell.
Sir, like carbon is in CO2, it is sp, right? Sp hybridized. So it is more electronegative due to more s character, and that's why since there is less electronegative difference, it is less polar. But whereas in ROR, the like carbon atom of R is sp3 hybridized. It might be. So it is like less electronegative compared to oxygen, and that's why the bond is more polar.
Suppose if the oxygen, that R group is sp hybridized means,
Sir, but
then how can explain?
yeah, okay, sir, got it.
Okay, so whenever you are getting polarity, you can explain through the dipole moment. That will be the best way. Okay, so if your covalent compound having ionic character means, that will be, you can explain through the dipole moment. If the ionic compound having some covalent character means, that you can explain through the Fedor's rule. Okay, the polarity and non-polarity where it will arise, if the electronegativity difference, exactly correct. If the electronegativity difference is arising when the molecule having symmetrical structure, so one side is plus of, another side is minus of, totally it will become 0, no? Okay, so even though the electronegativity difference is there, they are also having same symmetrical structure, definitely the electronegativity becomes 0. Sorry, the non-polar polarity become non-polar. Okay, so the dipole moment is the best way to explain it. Okay, ma?
Yes, sir.
The next one. So what will come in the place of A, B, C, D? Very good, very good. So when you have the phenol with the zinc dust, so just before we discuss, when the
Benzene.
phenol is, huh?
Benzene.
Benzene, very good. When the benzene treated with CHCl3 and AlCl3, it's a Friedel Crepes alkylation. It
Toluene.
becomes toluene. When the toluene treated with chlorine in the presence of light. So please remember, when the chlorine
Benzyl
in
chloride.
the presence of light, it will give Cl dot. Okay. So if it is a radical, definitely it will go in the place of methyl, not in the place of CH3. So the chlorination you can do two different way. When you are using chlorine in the light, it will give the benzyl chloride. Same way when the toluene, you are using chlorine in the presence of AlCl3, you get orthochlorotoluene or parachlorotoluene. Okay, that's why it's become different. Then when you are treated with sodium hydroxide, it becomes benzyl alcohol. Yes,
Sir, in chlorine in dark will give you
the bottom one. Bottom one, pa.
okay, sir.
That's why that also I have written. The OH, huh? I could not write. Okay. So what is the A, B, C, D? A is your benzene, B is your toluene, C is your benzyl chloride, D is your benzyl alcohol. So in case of AlCl3 or dark, it will give. Okay. Next question. Conversions, you have to remember many things, but you can score easily. So how would you achieve the following conversions? Now, how many questions? Oh my God, many questions are there. So how would you achieve the following conversion? Nitrobenzene to anil. How will you?
Fe bar HCl.
Hmm?
Reductions.
So first one you can use iron bar HCl or iron bar tin and HCl. Both you can reduce and you will get that. Okay. So nitrobenzene become aniline. An alkyl halide to quaternary ammonium salt.
Ammonolysis.
Okay. You can use. What is the reagent that you tell me? When you having or Cl3, just you are removing with ammonia. Okay. Just you have to add. It will give the quaternary salt. Okay. And then aniline to benzonitrile.
Diazotide and CuC.
Very good. So if you are using HNO2 and then CuCN, okay, then you will get very good. So that conversion would be
Sir,
fine.
third one alone can you write?
What no?
Third one alone can you write?
Or yes, okay. இப்படி கேட்டீங்கன்னா நல்லா இருக்கு கேட்கறதுக்கு. In H2, when you are doing HNO2, 0 to 5 degree, it become N2 plus Cl minus benzene diisocyanate chloride. When you are treated with copper cyanide, CuCN twice, it become okay. Okay, Appa.
Yes, sir. Sir, how to prepare isocyanate, sir? The naming reaction is there, right?
Gabriel toluene and the reaction. Carbylamine reaction. Carbylamine reaction.
Okay, sir.
That way you can prepare.
Okay, sir.
So chromium 3 plus is paramagnetic, while nickel it's a diamagnetic. Only thing, cyanide is a strong fill ligand, so it will pair all the electron in the system. Okay, that's why it's diamagnetic. Ammonia is a weak ligand when compared to cyanide. Okay, so the electrons are you can fill in T2G orbital as well as EG orbital. Definitely you will have 3 electron will be unpaired. That's why it's a paramagnetic. Okay, nickel is 28. Cyanide is a strong fill ligand. When you are writing, you will get the diamagnet and square planar complex for the nickel. So it's ionization isomer. How you can say? First one, if you are treated sulfur in the outer side, okay, it's a primary valency. When you are treated with barium chloride, it will precipitate barium sulfate. Same way, that second one, if you are treated with the same barium chloride, it will not react. Okay. Then if you are treated with AgNO3, it will give AgCl precipitate. So by that way, you can say that it has ionization isomer. Okay. அடுத்து How would you achieve the phenol to anisole? Anisole means what is the structure?
Benzene ring connected to OCH3.
So how would you achieve OCH3 from phenol? How to?
Sir, the product is RO or ether, right? So we can form
Hmm.
Williamson synthesis. So for that we need
What you need? Correct. Williamson ether பண்ணலாம். Dimethyl sulfide use பண்ணலாம். For
But
Williamson ether
treating
synthesis. Hmm.
but treating with alkali and CH2Br.
CH2,
Br.
CH2Br or CH3Br? Methyl bromide or methylene bromide?
Methyl
CH2Br
bromide.
எங்க? Methyl bromide. Okay, that you can. Then ethanol to propane to all. How would you achieve? Because this conversation is easy. 31. And tell me the next one. Ethanol
PCC,
to
PCC and Grignard reaction.
CH3, CH2OH. This into PCC, yeah. Pyridinium chlorochromate. It becomes CH3, CHO. When you are treated with methyl magnesium bromide, you will get CH3, CH, CH3, OH, 2 propanol. So we will achieve. So write the mechanism of the following reaction. Because ethanol இருந்து ஒரு ஹைட்ரஜன் போயிடுதுன்னா C3CH2 plus இருக்கும். So beta elimination water molecule. அந்த C question answer பண்ணுங்க. Why phenol undergoes electrophilic substitution more easily than benzene? So the OH group, oxygen, which involve resonance with the benzene ring. So ortho and para portions are more. So the negative part when you are writing the resonance structure.
Sir, can we tell OH being electron releasing group and increases the electron density at ortho and para?
That's why. That's why I'm writing. When it comes to the ring, so goes like this. So now the benzene ring become okay. Now it can donate here, so it goes like this. Okay. Now look here. This portion, this portion, this portion. Phenol ortho and para portion இருக்கா? Electron richer. Already have 3 double bonds. Along that, the portion of ortho and paras are very electron rich. That's why they are going electrophilic substitution. Electrophile means E plus charge. So these 3 portions are negatively charged. So then it immediately undergo the reaction faster rate. Whereas benzene ring there is no such effect. So the benzene ring will undergo electrophilic substitution reaction. There is no doubt about it. But the phenol goes faster rate because that group which influence the ortho and para portions are more electronegative. So more electron rich. That's why they undergo faster rate. Okay. Okay, pa.
Yes, sir.
So primary structure, secondary structure of proteins, அது அப்படியே நீங்க எதுதான் எழுதணும். ஸோ அமினோ ஆசிட்ஸ் எப்படி வந்து அமின் குரூப் ஆசிட் குரூப் ரியாக்ட் பண்ணதுன்றது பிரைமரி ஸ்ட்ரக்சர். செகண்டரி ஸ்ட்ரக்சருக்கு நான் சொன்னேன். ஸோ இட் ஹேவ் ஆல்ஃபா ஹெலிகல் அண்ட் பீட்டா பிலேட்டட் ஸ்ட்ரக்சர். ஆல்ஃபா ஹெலிகல் ஸ்ட்ரக்சர் பேஸ்ட் ஆன் த ஹைட்ரஜன் பாண்ட். ஓகே, அது அடுத்து how would you follow the conversion carried out? Propane to propane to all. Propane to propane to all. Benzyl chloride to benzyl alcohol. இதுக்கு முன்னாடி கொஸ்டின் பேப்பர்ல இருந்தது இல்லையா? ஏபிசிடி அச்சீவ் பண்ணமே. Phenol to benzene, benzene to methyl toluene, toluene to benzyl chloride. Oh, benzyl chloride to benzyl alcohol. Same thing you can use. Ethyl magnesium chloride to propane one all. எப்படி வரும்? Methyl magnesium bromide to methyl propane 2 all. 2 methyl 2 propanol. எப்படி வரும்? 33, 34, 35. அவ்வளவுதானா? 35 தான் லாஸ்ட் கொஸ்டின் இல்லையா?
Yes, sir.
ஓகே, நம்ம அது வரைக்கும் கம்ப்ளீட் பண்ணிடலாம். So arrange the following compound in the decreasing order of basic strength. You know that when your methyl groups having the methyl group increase the basicity of amine. According to that, so you have ammonia, methylamine, it's a primary methylamine. Methylamine is primary. Dimethylamine is secondary amine. Trimethylamine is a tertiary amine. So the amine group which is attached with 3 methyl group are more basic than secondary, which in turn more basic than primary, then ammonia. This is what we are explaining. Okay, in the ammonia, the hydrogen is attached with 3 hydrogen, whereas the primary methylamine, one of the hydrogen get replaced by one methyl group. Methyl group is the plus I group, so which can increase, it can donate the electron through sigma bond, so the stability will increases. So this is the order when you are following in the gaseous state, but the actual order is secondary amine, then primary amine, then tertiary amine, then ammonia. Yes, tell me, Pa.
Yes, sir.
What's your doubt, Ma?
Yes, sir. This only, sir. Yes, got it.
Okay. So due to the steric reason, okay, so the tertiary amine 2 methyl group can hinder the nitrogen. So the availability lone pair is available, but it cannot obstruct the proton as like your secondary and primary. That's why the basicity decreases. So due to steric effect. Even when you are thinking tertiary is a stronger base in the gaseous medium, the secondary is the stronger. Because of the steric effect, the tertiary become stronger one. Okay? Sorry,
Sir,
secondary becomes stronger, then primary, then tertiary. So this is the correct order.
sir, for the general case, this will be the order, right?
For green is the general case. When
Okay.
they are asking for the gaseous, red is the answer.
Sir, for general case and aqueous solution will be the same.
Yes. So only gases you have to answer this. For the general or liquid state, you have to answer this. Please remember, because sometimes they may ask in the gaseous medium also. So you know that when the randomness is more for the gaseous state, that's why that follows tertiary, secondary, primary. Steric வந்து கம்மியாயிடும். ஆனா லிக்விட்ல சாலிட் ஸ்டேட்ல வரும்போது இதான் ஆர்டர். ஓகே,
Yes, sir.
ஸோ ப்ரொபேன் டு ப்ரொபேன் டூ ஆல் எப்படி அச்சீவ் பண்றது? இது ப்ரொபீன். எப்படி? ப்ரொபனால் டூ ப்ரொபனால், தட் மீன்ஸ் CH3 CHOH CH3. ஸோ இந்த இடத்துல ஹைட்ரஜன் வரணும், இந்த இடத்துல ஹைட்ராக்சில் வரணும். அப்ப என்ன மெக்கானிசம் போட்டீங்கன்னா ஹைட்ரஜன் அங்க போகும், ஹைட்ராக்சில் இங்க வரும்.
Protonate.
Marconi.
ஸோ மார்கோனிக் ரூல்னா என்ன ரியேஜென்ட் யூஸ் பண்ணுவோம்? கரெக்ட்,
Water.
மார்கோனிக் ரூல்.
Water.
வெறும் வாட்டர் போட்டாலே வந்துருமா?
H plus.
So water in the H plus. Good.
Ah,
So when you are putting H plus, the H plus added over here, it will create a secondary carbocation. When the OH coming here means it will follow. Correct. So and then benzyl chloride to benzyl alcohol using sodium hydroxide. Okay. And then ethyl magnesium bromide CH3 CH2 MgCl that become CH3 treat this with formaldehyde. Will you achieve that? Is
yes.
it possible? அவ்வளவுதான். And then methyl magnesium bromide CH3 MgBr. So what is that they are asking? CH3 So இது எப்படி வரும்? Simply you take
Ketone.
acetone. Okay. What you are saying? What's your answer?
Yes, sir. Any like ketone, like acetone, right?
Acetone only.
Yes, sir.
CH3 CO CH3. Okay. Clear? Is it clear, Pa?
Yes, sir.
So that's all about today class. I think it took 2 hours, right? For discussing one question paper, it takes 2 hours. Is it useful to you?
Yes, sir.
Yes, sir.
Don't say lies. Sir, okay, shall we wind up the class?
Yes, sir.
Any other doubts? Any other doubts?